Hi, tonight I want to talk about torque and how to torque your nuts and bolts without a torque wrench. As you know, there are some bolts and nuts and similar things that we need to torque to specified settings. The go-to tool is a torque wrench, but not always we can use it, and there are other methods. And what you can use a digital scale like this. This is not a scale, but it is a tool that measures the power of your hands. But at the same time, if you connect a rope on the end, you can use it to show how much you can pull, you can produce. So something similar you can use. There are luggage weights. There are things that you can weigh your luggage and this kind of stuff. If you make a Google search, this kind of things that you can use to torque your bolts. To be able to use this machines, you need to translate the Newton meter or foot pounds, I guess, foot pounds torque settings into centimeters or your country's measurement thing, if you're using feet or foot or something. And we are using centimeters here. So what you need to do, you need to translate this Newton meter into a usable thing. So what I did, I make a easy chart that you can use. 1 Newton meter is 1 centimeters of wrench with a 10 kilogram of pulling force. It's a bit confusing. What does it mean? Let me show you with a nut, the bolt and the wrench. So what it says 1 Newton meter is 1 centimeters and 10 kilograms. What does it mean? If this wrench was just 1 centimeters long, and if we wanted this bolt torqued down with 1 Newton meter, then you need to pull this 1 centimeter wrench with a 10 kilogram of torque, the torquing force, that twisting force. So let's take it into a bit reality. Let's say that this wrench is 10 centimeters long, and we still need to torque this bolt with 1 Newton meters. Then what happens is 1 Newton meters is equal to 1 centimeter of a wrench with a 1 kilogram of pulling force. And what does it say is that if you make the arm, if you make the wrench longer, your pulling force goes down the same amount. So if you multiply the length by 10, you divide the pulling force by 10. And as you can see, they have what was the equation, but you understand, I guess. Sorry, my English is not that good, I guess. And what is the connection between the Newton meter and the kilogram and the pulling force? They have a direct connection. So if you make the Newton meter up, if you make the Newton meter go high, then you make the kilograms, the pulling force, go up as the same amount. And let's make a calculation. Perhaps it may help you a bit more. Let's say the engine manufacturer or someone else tells us we need to torque a bolt with 12 Newton meters, and we have a wrench that is 20 centimeters long. So how can we achieve the 12 Newton meters torque with a 20 centimeter wrench? We are going back to this 1 Newton meter is equal to 1 centimeter, 1 centimeter and 10 kilograms. And first we do the easy maths, and we say that they are going in the same direction. If one goes up, the other also goes up. Newton meter and kilogram. So if we multiply the Newton meter with 12, then we also multiply the pulling force with 12. So if 1 Newton meter is 1 centimeter is 10 kilograms, 12 centimeters, 12 Newton meters, 1 centimeter, 120 kilograms. Let's multiply by 12. And then we need to change this into a 20 centimeter range. So what happens? That we multiply our range, the centimeter, 1 centimeter by 20, but these are opposing forces. So if we multiply this, we divide this. So our range is now 20 centimeters, and we divide the kilograms by 20, and we have 6 kilograms. So in the end, with the calculation, if we want to have 12 Newton meters of torque with a 20 centimeter range, then we need to pull it with 6 kilograms. And let's see it in real world if I can show. And yeah, this is the setup. That's the measurement tool you have, and you connect a wrench, and then there is a hint here, and you check the length of the wrench not from tip to tip, but from the turning points. So the turning point of this nut is in the center, so we are checking the length not from the tip but from the center. The same time we are checking the length from where we pull, and it will be again from the center, as I can say. You won't be pulling from the tip, but you will be pulling from the center. So let's check if it's really 20 centimeters. And centered, as you can see, it's pretty much 20 centimeters. So that's the hint. Let's put the machine on and let's try to pull it. I need a bit of leverage here. Okay, I start pulling, and then we need to stop when we see 6 kilograms. And I stopped at 5.8 because I wasn't able to pull. And yeah, we saw a bit high, 6.2, but it won't kill anybody, I guess. So I guess that's all I can say about it. I hope it is useful. It was useful information for you. Hope you enjoyed it. I'll be glad if you subscribe or leave a comment. And thanks for watching.